Lesson 4.2.1 Introduction to Energy, Potential, and Lesson 4.2.1 Introduction to Energy, Potential, Energy. At least 80% proficiency. Students should be able to identify several forms of energy, to distinguish between kinetic and potential energy, and solve problems involving potential energy. Energy, who needs it? The nature of energy. You can hear energy as sound, you can see energy as light, and you can feel it as wind. You use energy when you hit a softball, left your book bag, compress a spring. Living organisms need energy for growth and movement. Energy also is involved when a bird flies, a bomb explodes, rain falls from the sky, and electricity flows in a wire. What is energy? That it can be involved in so many different activities. Energy can be defined as the ability or capacity to do work. If an object or organism does work, that is, if it exerts a force over a distance to move an object, the object or organism uses. Because of the direct connection between energy and work, energy is measured in the same unit as work, joules. In addition to using energy to do work, objects gain energy because work is being done on them. Here are the forms of energy: radiant or electromagnetic energy, electrical energy, chemical energy, sound energy, thermal or heat energy, and mechanical energy. Radiant energy is also called electromagnetic energy. Radiant energy is the movement of photons. All life on Earth is dependent on radiant energy from the sun. Examples of radiant energy include radio waves, AM, FM or TV, microwaves, X-rays, and plant growth. Active solar energy uses photovoltaic panels and light to turn radiant energy into chemical energy. Chemical energy is the energy stored in the bonds of atoms and molecules. Fossil fuels and biomass store chemical energy. Products that contain chemical energy include TNT, baking soda, and a match. Biomass, petroleum, natural gas, propane, and coal are examples of stored chemical energy. Electrical energy is the movement of electrons. Lightning and static electricity are examples of electrical energy that occur naturally. Science hasn't found a way to use natural forms of electrical energy like lightning. Instead, we use different energy sources to create electrical energy by using generators and turbines. Nuclear energy is the energy stored in the nucleus of an atom. Nuclear energy is unusual in that it can give off energy in the form of light or heat, but it is the change in the atom's makeup that produces the energy. Submarines, power plants, and smoke detectors all use nuclear energy. Nuclear power plants use uranium, a radioactive element, to create electricity. Thermal energy or heat energy is the internal energy in substances, the vibration and movement of atoms and molecules within substance. Thermal energy is created in the movement of atoms. Boiling water, burning wood, and rubbing your hands together really fast are all examples of heat energy. Thermal and passive solar are sources of heat energy, but biomass, a type of chemical energy, can be burned to produce heat. Sound energy is the movement of molecules in the air that produces vibrations, alarms, music, speech, ultrasound, medical equipment all use sound energy. VCR tapes change sound energy into electrical energy. The electrical energy records the sound using magnetic tape. Speakers read the magnetic tape and change it back into sound. Mechanical energy is energy due to its position or motion. Wind up choice, grandfather clocks, and pogo sticks are examples of mechanical energy. Wind power uses mechanical energy to help create electricity. The types of mechanical energy are 1. Potential energy. This is energy due to its position or stored energy. And this is further subdivided into gravitational potential energy and elastic potential energy. And the second type of mechanical energy is kinetic energy, which is energy of motion. Examples of potential energy. Stretching a rubber band stores energy. Water at the top of a waterfall stores energy. Yo-yo held in your hand stores energy because of position. And drawing a bow stores energy because of position. Let's start with the potential energy or energy of position or condition. The first form is gravitational potential energy. Is written in the form PEG equals mgh, where m is the mass of the object in kilograms, g is acceleration due to gravity, 9.8 meters per second squared, h is the height of the object in meters from some arbitrary reference point, and Pe is the gravitational potential energy. Unit is joules. From the gravitational potential energy, which is equal to mgh, we notice that the greater an object's mass, the greater its gravitational potential energy. The greater an object's height, the greater the gravitational potential energy. Doubling an object's height will result in doubling of the potential energy. Tripling the height will increase potential energy by a factor of 3. Let us do some examples now. Sample 1. What is the gravitational potential energy of a 1.3 kilogram book that is placed on a shelf that is 2.4 meters high? Solution. Using the formula PG equals m times g times height and substituting the values, we have 1.3 times 9.8 times 2.4 equals 30.576 joules. Example number 2. The potential energy of an apple is 4.5 joules. The apple is 3.2 meters high. What is the mass of the apple? From PEG equals mgh and solving for m, we have m is equal to PEG all over g times h. And substituting the values, we have 4.5 for PEG over 9.8 times 3.2, and the answer is 0.14 kilograms. Example number 3. You are on roller blades on top of a small hill. Your potential energy is equal to 1,400 joules. The last time you checked your mass was 60 kilograms. What is the height of the hill? From formula, PEG equals mgh, solving for h is equal to PEG over m times g. And substituting the values and simplifying, you get 2.38 meters. Example 4. A 50 kilogram person is on the ground floor of a 10-story building. If each story is 2.50 meters high, what is the gravitational potential energy of this person relative to ground floor if he is standing on the 5th floor? From formula, PEG equals mgh. Since this is the 5th floor, therefore every story is 2.5 meters high. Therefore, the 5th floor is 5 times 2.50, and the result is 6,125 joules. When the person is in the 7th floor, PEG equals mgh, but this time the height will be 2.5 times 7. So substituting the values, we get 2.5 times 7, and the result is 8,575 joules. And when he is in the 9th floor, the PEG now is mgh, which is 9 times 2.5 as the height, and the result is 11,025 joules. If there are no more questions, then let the students complete the classwork until the end of the period.